Right, here's a very typical example of your derivative function. Okay, they give you a picture, a parabola like this, and this graph is representing the derivative function. There it's telling you over there y equals f prime x, okay? What are the first things you should be noticing about that derivative function? Well, I've got x-intercepts at -1 and 0. And remember that the x-intercepts of the derivative function form the x-coordinates of your turning point of your cubic function. That was from the last video. Right, so we've got this picture, and the first thing they're asking me to do is determine the equation of f prime x. Okay, so they're asking us for the derivative of the equation of the derivative. So basically it's this. This is the graph they're asking me for the equation of, which is a parabola. Okay, now parabolas, to find the equation of a parabola, there's a similarity between finding them a parabola equation and a cubic equation, especially when you've got x-intercepts, okay? Do you agree? If you look at this, I know what the two x-intercepts are, all right? If we know that, our starting point needs to be here. We need to say that y equals a multiplied by x minus x1 multiplied by x minus x2, but obviously I'm not going to have a third bracket because it's not cubic, it's just quadratic. And we're going to substitute into the x1, your -1, and the two negatives make positive, and x minus 0. Okay, so we've got those points. And then we use another point on the graph, which in this case is -2 and 12, and we sub them into the relevant x and y values. So here -2 is going into my x, and -2 again goes into your x. Okay, so that's leaving you with the a value to solve. That's giving me a -1. This is just -2, so therefore it's +2. 12 divided by 2 is 6. That's your a value, okay? Now that we know the a value, we just plug it all back and we say 6, I've got x plus 1, I've got x minus 0, which I'm not even going to write anything. Minus 0, we just leave it off. And what does that give me? A final equation of y is equal to 6x squared plus 6x. Okay, so that's the equation that represents your derivative function. All right, so in fact, the way we could write it is to say f prime x equals 6x squared plus 6x. Okay, right, now let's look at the second part. Now it says determine f of x. So now f of x would be the cubic function, because it's going back to the normal f of x. If the f of x function is, and you see to some extent they've actually given me a bit of a clue as to what the equation needs to look like. The constant term I already know is -2. I just need to basically find the a and the b. Okay, now this is how we are going to do it. We have just worked out that the derivative function is the equation 6x squared plus 6x. Okay. What we're going to do, guys, is we're going to do the rules of differentiation, but I'm actually going to do them in reverse, okay, because you understand we're going from the derivative back to the f of x function. So we're going to do everything the other way around. And the way that works is as follows. We are not going to subtract 1 from the exponent. We start by adding 1 to the exponent, which is giving me 3. Okay, so this is getting us back to our original f of x. I take my coefficient, okay, so that became 3. I take my coefficient of x cubed and I divide it by whatever the exponent was. So I'm going to divide that by 3, all right? Then the next one, so if that already had an exponent of 1, I'm going to add another 1. So we're sitting with 6x squared, and I have to divide my coefficient by the exponent. So I'm going to divide it by 2. Okay, so that's giving us what? 6 divided by 3 is 2x cubed. I'm getting 3x squared. Now, this is quite, just listen carefully to this. When you're finding a derivative, in fact, let me give you a quick, let's just quickly talk about this as an example. This is a totally different example. I'm just trying to illustrate something to you here. 6x minus 1, let's say. If I found the derivative of this, okay, it would be 6x plus 6, and that 1 would fall away, all right? So if I was going from this and I was going back to the original f of x function, how would I have any idea that that negative 1 was there? Because it was a constant that fell away, all right? So the idea is technically that we should, in order to account for the missing, sorry, I'm just going to erase this now because I don't want you to get confused. I was just discussing the concept of that constant. So the idea is that if I'm going from this derivative back to the original x function, how would I know if there was a constant term sitting on the end or not? Well, essentially we don't know, so we have to fill in a plus c, okay? Now they were nice enough in this particular example to tell me what that was. It was negative 2, okay? And yeah, in this case, at this level, you're going to be told it if you need to know it, okay? So 2x cubed plus 3x squared, and then they gave it to you in the original part that c value was negative 2. And that is your original f of x function. That's the cubic function that you would get from the derivative function. All right. Good. Okay, I hope we're making progress with that and you're understanding it. If you need to go back and listen to the video prior to this one just to understand that, do it. Okay, it's an easy concept and it's a nice one to get marks on. It just takes a little bit of understanding. All right, keep it up. Good work. We'll see you next time.